Good morning, good afternoon, good evening, wherever you are in the world. Thanks for taking time out of your busy schedules to join this webinar. Today, we're going to explore how adaptive lighting can help cities create safer, more efficient and more sustainable roads. I'm David Orchard. I'm delighted to be joined by David Denner from the Welsh Government. For anyone who remembers the two Ronnies, we're the two Daves, similar, but definitely not as funny. Together, we're going to walk you through the technology, both the technology and real world deployment, so you can see the benefits in action. Our goal today is simple: to help you understand how your existing lighting infrastructure can work harder for you, improve safety and reduce energy consumption, all without compromising standards or service levels. So with that, we'll begin. Just before we do, let's just review who we are as Signify. This is our company by numbers. A couple of items I wanted to pull out because it's pertinent to what we're talking about today. So Signify, we are the leader in connected lighting in home, in cities and in the workplace. We've got over 160 million connected light points worldwide. We're also on track to reduce greenhouse emissions by 40% by the end of last year as well. So some big numbers there. Most of you will probably know Signify, founded as Philips in Eindhoven in the Netherlands, but we've led the lighting industry with innovations that serve the professional and consumer markets for nearly 130 years. We provide high quality lighting products, systems and services, and have a simple, clear purpose to unlock the extraordinary potential of light for brighter lives and a better world. Sustainability really is at the core of our purpose, not only our innovative, environmentally friendly products that improve lives, but also how we operate as a company. We're committed to achieving carbon neutrality and providing access to light for underprivileged and underserved communities. Just a little bit about me. You can sort of read it on the screen. We're not going to go into it as usual with these things. It makes me sound grander than I probably am. I'm commercial segment leader for Signify in smart street lighting. I've been in the lighting industry for many years and in the controls and connected space as well. And like I say, really pleased to be with one of our key customers over the last number of years, David Denner. So David's based down in Cardiff and is currently a highways technology manager for the Welsh Government. I'm sure he'll explain a little bit more about what he does. But again, I've worked with Dave for many years. He brings huge experience from previous roles that he's done, and he's got a great skill set that includes lighting, but also many other parts of the roads and highways as well. So we'll get started. So urban environments, we know that they're facing increasingly complex challenges. So whether it be traffic congestion, unpredictable weather patterns, rising road safety concerns, and a pressure to reduce carbon emissions. And our traditional static lighting doesn't adapt to changes in some of those things, so traffic flow, visibility, weather. And this really results in wasted energy and compromised safety. Adaptive lighting allows cities to respond dynamically using real-time data from sensors or existing data systems. This improves visibility when it matters most, reduces unnecessary energy consumption during quiet periods, and contributes to those sustainability targets. Now, let's have a real example of how these principles translate into measurable outcomes. So I'm going to hand over to David Denner to walk you through how the Welsh Government decided it was time to make their lighting work harder for them.
Yes, thank you, Dave, and welcome everyone. As you can see, the date on this slide is November 2025. This was the first time we give this presentation to the UK electrical industry. There was a meeting held in Wales of all the major contractors, suppliers and clients, and we were able to present this information to the UK, and it has generated a lot of interest as well across the UK, particularly for the strategic road operators, of which I'm one of them. So Wales has 22 local authorities, municipalities, but the strategic roads, the motorways, the autobahns, those major roads are all managed by myself with a lot of lighting. The problem with a lot of lighting is there's a lot of wattage, a lot of energy usage. So what we will do during the next few minutes is talk about what we've done in Wales to actually minimize that impact. So next slide, please, Dave. So I think we couldn't have a discussion around anything these days without showing some of the problems of climate change around the world. I think everyone will acknowledge that the sea temperature is going up, the ice caps are melting, the corals are losing their colour. More and more forest. I have family who live in Australia, and there's lots of forest fires all the time because of, again, all the effects of global warming. Whether you're a believer, whether you're a skeptic, the science speaks for itself. So basically, we can't keep doing what we've been doing. Otherwise, what will the next generation have? And that's really the impact that we have. In Wales, the government have legislation that says that basically anything we do today, it's called the Future Generations Act. We can't then do anything which is going to cause a problem for the next generation. And that's really so important. And that's where I'm excited to sort of trying to make the world a bit better place and do my bit for the environment as well. Next slide, please. So across the UK, most of the government departments, there are about 300 municipalities, local authorities, whatever you call them in your part of the world. But basically, many of them have declared what's called a climate emergency. So that means that they've all sat around a table and decided that they need to do something. We can't keep burning oil. We can't keep using the natural resources. We need to do more recycling. We need to do upcycling. We need to make better use of the planet. Now, obviously, certain events, linked in with that, such as the COVID pandemic worldwide, a lot of people now work from home. There's a lot less travel. But then even though car usage might have gone down, the delivery for packets to our home, these sort of companies are maybe sending more lorries out and vans out on the road. So we've got to get that balance right. So a climate emergency is very important. So Dave mentioned that Signify are a leader in providing LED roadway solutions. So next slide, please. Now what you can see here is a snapshot. So we did a survey right across the UK as to the profile of the various lamps. So just over 7 million streetlights across the UK, and that includes Northern Ireland, of course. And so you can see that we're on a journey. This data was a couple of years old. We are looking at refreshing this and doing another survey, and hopefully the parts of the circle on the right-hand side will be expanded. But you can see, over 50% of LED, but there's still a lot of work to be done. And a lot of the other older lamp technology, maybe are on older lighting columns. So there's no point putting a brand new lantern on an old column which needs changing. There's a lot of cable infrastructure in the United Kingdom. A lot of the lighting went in the sort of the 50s, 60s, 1960s after the war. A lot of roads were built. So a lot of the cable that's in the ground, a lot of the lighting columns are very old. So it is a challenge, but we are getting there slowly. And of course, on the next slide, please, Dave, you can see here that in Wales as a country, we have a population of about 3 million people. Mainly, it takes, we have a lot of strategic roads, mainly the east-west links. So anybody who's ever been to Wales, across the South Wales, you have the M4 corridor, which is the motorway, which takes you across then to catch the ferry to Ireland. And across the north of Wales, we have the A55 corridor, a European route. And again, that's the second busiest port in the UK, Holyhead, for traffic across to Ireland. But what you can see on the chart on the left-hand side is our energy consumption. So when I started with Welsh Government, we started collecting data, and we were about 21 gigawatt hours of electricity being used. And over the years, working with Signify, changing our LED lanterns, going maybe from 400 watt high pressure sodium lanterns to 145 watt LEDs is our standard now. You can see we've brought our energy consumption down. We're around about now 14 gigawatt hours. The problem being is if we're keeping all the lights on, we have plateaued at that level. So it's going to be very difficult. Once we've made the switch to LED, where do we go next? That's the challenge. That's the question I get asked. So next slide, please. So what do? How do we reduce our energy demand? Well, I think the comment on the slide there, lighting empty highways is wasteful. If I could see you all and we were all in the same room and I did a survey, I said, how many of you leave all the lights on in your house when you go to bed? It's nonsense. We would never do that, would we? We go to bed, we close our eyes, we turn the lights off. So it's the same with the roads. if we get in less traffic in the middle of the night, so at 2, 3 o'clock in the morning, our traffic volumes are very, very small, mainly commercial traffic. But why are we still lighting the roads to the 100% brightness at 4 o'clock in the evening? So we thought, right, what's the challenge? How can we get around this? Well, we know that we can't just go turning lights on and off. There has to be standards, specifications. These are the rules we all live by. So next slide, please, Dave. So the Institution of Lighting Professionals, they have guidance on lighting levels that we like to, but they also have tolerances based on the traffic flows. And normally when a road is being lit for the design, it's based on the usage of the road at peak traffic volume. So we put all these lighting in, but then we don't take into account that there are a number of hours during darkness when the road isn't being used to the peak volume. So what we thought we would do is, obviously using our CMS system, using our radar system, etc., we would then look at some adaptive lighting. Now I'll hand over to David now, who's going to explain a little bit of the history of adaptive lighting across the UK and the world.
Thanks, Dave. So, yeah, I think a bit of the history of traffic adaptive lighting. I think the thing to say is, and as much as on this call today, it might be the first time people are hearing about it, but adaptive lighting and traffic adaptive lighting isn't new. But I think we're at the stage now where the technology has matured, where it really makes sense. So you can see on the left-hand side, well over 10 years ago, there were some early experiments done over on the West Coast in the US with a Houston radar, so dedicated traffic radar. But really, it was before its time. Dimming wasn't really a priority. LED was just coming in. So nothing really happened from there. Moving forward, sort of 2015 to 2017, then we at Talenza did a number of trials with some customers using some early AI devices and also some radars as well. So very much around sort of camera and radar based. So I mean, some of those early devices even had like blue tack to hold them up. It was very early days for some of this technology. So as we move forward into the radars, we actually saw some really good success in the systems and how they were used. But as much as the technology was successful, the business case just wasn't there. Having to put in additional infrastructure all the time then just didn't make sense with the amount of savings you could get from the dimming. However, now we're looking to integrate using existing data that's already there. Welsh Government are leading the way in taking this to scale, and we're starting to see globally now a real mainstream interest and adoption. So I think the point here as Signify is we've learned an awful lot along the way, what works, what doesn't work, and how to help you build business cases that deliver real value. And a simple thing of how does it work? So very simply, here's the sort of basic flow. So traffic and also weather data is collected. This can be via sensors that are already deployed on networks, can be added to networks, and there are other data sources out there which are already collecting data. And then the streetlights can be grouped and adjusted gradually to avoid driver distraction. So groups of streetlights can be grouped together. As Dave said, lighting empty highways is wasteful. So this is a really simple way of coming up with a solution to that problem. All the adjustments happen in real time, and as we also said, it ensures safety and complies with national standards, which obviously are different in country to country. So why dynamic lighting? I mean, you can see on the top really the journey we've gone through in the last 15 years, from conventional lighting to LED to smart lighting, so the sort of standard CMS, and then into dynamic adaptive lighting. As we've said, streetlights often stay at full brightness when the roads are empty. Having adaptive lighting reduces that energy waste and light pollution. It maximizes the financial savings by only lighting when and where required. And it also minimizes the risks by always delivering the adequate lighting levels. This ensures our roads are adequately lit when needed and intelligently dimmed when not. So I'm going to hand back over to Dave to walk you through how Welsh Government's traffic adaptive lighting project delivered significant energy savings while maintaining and in some cases improving service levels. Over to you, Dave.
Thank you, David. And as a reminder, if you do have any questions, please feel free to put them in the chat and we can pick them up then at the end as well. So what you see on this slide, and the reason we wanted to present this is basically this isn't an easy thing to do. When Dave and I were first talking about this maybe 10 years ago, it was our aspiration, but we weren't quite ready. So what we had to do was bring a whole team together. So on the slide there, we know we had like Signify for the LED lighting, but then we had tailor for the smart control of the lighting. We needed our contractor on board to trial these things because anything new, nobody likes any risk. Our supplier of our software, which is our database for our energy purposes, they had to be on board as well to collect all the data. They were a company we deal with who collect all the traffic count data, because the only way we could make this work. So they had to write an API to talk to tailor. Now, in days gone by, there would have been distinct servers sat in different buildings that could never talk to each other. But as we moved on, we're in 2026, a lot of these companies now, they have their hosting in the cloud, either Microsoft Azure or Amazon Web Services, so they can now talk to one another. And then, of course, we needed a way of counting the cars, counting the vehicles. So we thought, well, radar is one of the best ways, accurate ways of collecting that data. So you can see the flow of the data and how everybody had to work together to get this over the line. Next slide, please. So this is a map of Wales. And as you can see, the sort of the east-west links. So what you can see there are a number of our traffic loop sites. So magnetic loops, as the cars drive over them, they generate a signal that's picked up and then that's counted and classified, which is great. But the problem we were having with the loops is when you want to do any work on the pavement surface, then very often the loops would be cut, and then it could take months and months maybe to get back out there to put the loops in the ground. So loop technology is tried and tested, but it's a little bit old technology, and we were looking for something a little better than that as well. So what we wanted to try to do is obviously use radar. So we fitted some radar sites up, and if you go to the next slide, please, Dave. We had some discussions, and so what you can see on the slide is some of the traffic flow information between motorway junctions in southeast Wales. And we decided to, based on the traffic flow, that we would set 3 different thresholds. And so obviously the normal peak flow would be 100%. So the lights don't dim at all. So to the driver, the motorist, they see the lights at 100%. When we drop to 1500 vehicles per hour, then we drop to 80% light level. And then at 500 vehicles an hour, that early hours of the morning, we drop to 60%. Now to the eye, it's very difficult, and I've been on site, and when you see these light levels, it's very difficult to see the changes. But obviously it has an effect, and the benefits to us from an energy consumption point of view. What we made sure we did as well was we didn't, if you go to the next slide, Dave, please. So we didn't change any of the slip roads. So any conflict areas, they're called in the British standard. So any conflict areas, we've left them at 100%. So the slip roads onto the roundabout, onto the gyratory, they're left at 100%. We're only dimming the main line. We also took the decision that we would group the lights together between junctions. We also made a decision that what we would do is we would dim, but we would dim both sides. So what the counting software does, talking to tailor, is it'll count all the cars or the vehicles and then aggregate them together. It's doing them real time. And then every 5 minutes, it says how many on an average have gone through. And then that'll send it to say, should I dim or not? And then tailor will then dim the lighting accordingly. The advantage is that we don't want a driver, say, driving westbound if it's very quiet, and then that's dimmed down, but the light on the other side is very bright. We wanted to keep it nice for the driver's eye, for the perception, and to make sure there was no glare. So we wanted to make sure that both carriageways, and remember this is the motorway, so it's 3 lanes of carriageway. The vehicles in this area, it's about 100,000 vehicles on an average, daily average. of traffic. So it's quite busy for us in Wales. It's our busiest section of the motorway, mainly the section around Cardiff, which is obviously the capital of Wales. So they were some of the rules that we set down. But one of the challenges I had was we got the loops out there, and we know the loops are very, very accurate. So everyone was a bit hesitant to say, well, if we're using radar data, how accurate is radar? So next slide, please, Dave. So what we did, we put a radar out, and this is an American product, a very, very good product brought into the UK. And the radar will do 16 lanes, and it's a side firing radar, and it will also classify, it's also got CCTV built into it. So what we did, we put the radar next to a loop site. And as you can see on the chart there, the blue line is the radar data, and the grey line is the MIDAS. MIDAS stands for the Motorway Incident Detection System, so the loops in the ground. And I think we'd all be confident that if we went over to the radar, you can see that the radar is very accurate, and it's almost mimicking to the loop sites. So we were comfortable after doing some testing that if we switch the radar on, we're going to be counting the right number of vehicles. Now, obviously, there's some discrepancies. The radar will bounce off. They might be on the radar. You might have one vehicle behind another vehicle, so the radar can't see it. So there's always going to be an element of inconsistency. But we were happy that we could go live with the radar data. So then, next slide, Dave. We took this radar data, we fed it into the Clearview platform. And the Clearview platform is great for traffic count data. And again, what you can see here is we get that sort of started on the left of the slide. You know, through the evening, the vehicles is very, very low. And then obviously as morning peak comes, as everyone gets up and goes to work, then we get the morning peak, we get the lunchtime drop off, and then the evening peak when everyone wants to go back from work, and then it drops off to midnight. So if you press it again, I think it brings up the points on this slide, Dave. So we got sort of 60% dim level, and then we go up to 80%, and then of course at 2,500 vehicles an hour, we said we'll go to 100%. So you can see, you know, we started this presentation off by saying, why light empty highways? Now, if nobody was using the road, we could in theory turn the lights off, but we don't want to do that because we don't know when it's going to be used. So we're constantly evaluating this to see if we can maybe get some more, drop the lighting level again, see what we can do. Maybe we can put extra increments. The advantage we have in Welsh Government is because we've partnered now with Talensa, we can do all of these different steps. We could turn the lights on and off, on and off, on and off all the time. I mean, we want to have some sort of consistency, and we don't want to be doing work for the sake of it. But I think you can recognize that there's some logic based on counting the cars, using the radar to dim the lights accordingly. But of course, how does this work in practice? Well, the next slide that Dave will show. Oh, and again, we go off to the dimming. But this slide, it's not easy. So if you're in the UK, and you're UK based, this is basically the flow chart, the process diagram that shows where all the data goes and how you end up getting an electricity bill. So at the top of the chart, you can see there's a customer, that's me. Then we send our inventory to our unmetered supply operator. We have Talensa, which is monitoring every street light and telling and capturing the data when whether it's at 100% power or 60% power. If there's an event, it all goes in the event log. That event log also gets sent to our meter administrator. They marry it all together with the inventory, the switch on, switch off times. That then goes to the half-hour data gatherer, which then goes to EDF, who is our electricity supplier of choice. So it's very, very complicated. And this is computers talking to computers, using APIs, uploading data. But this was something that we wanted to do for a long, long time. But it has taken a lot of time to get us to where we want to be. So all of this process paid off. And if we go to the next slide, what does it mean? Well, it means on this section of motorway in Southeast Wales, we got about 2,000 lights now connected into the system. The new LEDs, as I said, we went from a 400 watt all the way down to 145 watt LED. We still meet all the standards. It's 3 lanes of motorway plus a hard shoulder. Our expected savings, £112,000 converted to kilowatt hours, converted to tons of CO2. But you can see, over a year, how much we are saving. So yes, there is a cost to put in radar in. Yes, there's a cost of putting the CMS in. But once we've done that, that's one time. We are now gaining this. And what we're rolling out right across the motorway, that wherever we have lighting, we will be putting in the radar. We will be using the APIs. All the investment now is paid for itself. So we'll be able to continue to do this on other roads. In the future, we could be looking at other ways of collecting car data, maybe floating car data, connected car data. All of this could maybe feed in. But at the moment, that's another ecosystem, that's another challenge. But just to really highlight that, this is really beneficial. And a few years ago, we used to give a presentation and we'd think this would be aspirational. This is what we would like to do. But this is, live. If you go to the motorway in South Wales tonight, you will see the lights dimming based on all of this technology. If we go to the next slide, please, Dave. I think what's key to this, and I know many of you might be Signify employees, but yet it's important to get everybody sat around the table. I think collaboration was what got this project working together. Signify, great at making LED products, maybe not so good at making counting car technology. We had Clearview, we had Renex Radar, we've had Talensa, we've had all the suppliers talking, we've had them writing APIs. It's been difficult, but we got there. And I think sitting down and communication. And one of the good things that come out of the pandemic is that there's a lot more of that collaboration, a lot more working together. As I said earlier, servers talking to servers, computers talking to computers to be able to make this happen. A lot of people are thinking, what can we do with this data? People talk about AI now, the future generation. This is AI in work, in a real-time environment, because it's using the intelligence we've got to do something with everything else. So I think collaboration has been a real good point of this project from start to finish. And hand back now to Dave as he details a little bit more about the Talensa platform.
Thanks, Dave. Always, great to see the project and see how all the collaboration together and obviously the outcomes, and looking forward to see how it sort of grows and scales over the course of the next sort of few months and years. So thanks for that. So yeah, just to go into the technology a little. A little bit on the roads, we're already collecting lots of data. So whether it's from radars, whether it's from loops, whether it's from cameras, there's also new generations of sensors coming out that can collect data. And we also talked about floating car data as well, things that are coming from from sat navs and from our phones as well. So they're all ways in the future that we can use for this platform. And cities aren't just collecting traffic counts from various sources, but also more and more things like weather, things like incidents as well, footfall, and adaptive lighting will enable us to use those existing data sets more intelligently, rather than just installing new sensors everywhere. We also use the existing data that's already out there. The system itself is super easy to use and easy to set up. You can see here this quite quickly shows all the current data points of where loops and radars are on the Welsh Gov network. So there's an easy view of how to set these up in the system, and just to go and configure the adaptive lighting is really super easy. So we've just got a couple of screenshots around that. So obviously we have a traffic configuration that we can do, so you can choose multiple sensors, you can combine those different sensors. Obviously you can set different sample rates, you can set the dim levels, and we talked about the vehicle count and the fact that things might be different in different countries, so therefore you can change these accordingly as well. And also with weather adaptive lighting, you can set the priority, so which one takes precedent over another one as well. And on the same on the weather, you can choose different weather parameters. So whether that be rain, snow, different temperature, humidity, you can also choose from current forecast or forecasted forecasts for those weather location, and choose the dim levels and intensity ranges as well. So really super easy to set up. And just sort of a reiteration of Dave's slides earlier, lighting classes really matter, but it's important to say that the system that's been, being provided here by Signify, it's there to meet the standards and regulations in different countries. It's fully user definable and adaptable. So it's we're not saying to you how the system should be used. It's very much user definable. So you can then match it to the needs that you have. So it's dynamic to fit within whatever lighting policy your city or region operates. And that's important because they do change from country to country. You take, and Dave touched on it with the UK's references that we have, but also in Italy, there's different traffic adaptive and then fully adaptive, including weather and luminance data of 3 and 4 different stage dimming levels. And I know around the world there are many other sort of national standards as well that we have to do. I guess a key question for people is, where could this lead us in the future? So we're sort of in this phase 1 at the moment. We call it contextual lighting. So we've talked a lot about that today. So dimming lights based on traffic flow to lower energy. And thinking of traffic, you can also think of things like cycle paths as well. But also you can build upon this with other vendors and other technologies as well. So things like camera vendors. We also touched a little bit on floating car data. So can we collect data from people's phones and sat navs as well? So, but there appears to be some really easy upgrades to make to the system to use more data. There's things already being looked at to add support for stationary traffic and what you would do in those situations. With the weather, you can include current weather, but also predicted weather. This might help with solar lighting in the future around the battery resources and when to use and not to use things. Footfall, so the busyness of places as well. Curbside monitoring to sort of have a look at the traffic flow there. We've got things like transport timetables as well. Also motion detection for bus stops, accident statistics. So there's a number of different ways that this could be used beyond what it's being used for at the moment, but the system is set up to then take various inputs and to adapt the lighting accordingly. So obviously this is what the future of dynamic adaptive lighting could look like, where you have various inputs that we just talked about, all feeding into the lighting and making sure that we have the right light in the right place at the right time. And I guess the main thing we've learned, we all hear this phrase smart cities, but that cities already have lots of data being collected, often across different departments and sort of different silos within cities and municipalities, but they can be used in conjunction with a lighting network. And essentially, this is about enabling you to sweat your assets, as in Dave already said. These things have already been paid for. So rather than just adding more on, you're actually, getting your assets to work harder for you. I think the best example, obviously, is traffic counting, as cities already have a huge amount of data at their disposal. So it's now about what can be done to tap into other existing data. So the beauty of this is there should be no further infrastructure cost because sensors are already out there. It's just using the data to help save more money on lighting or make our cities and places safer. And as you can see, there's lots and lots of companies Dave mentioned around the sort of ecosystem of partners that were out there, and there's lots of companies out there. No one company's going to do it all, but having interaction between the companies, we can make a solution which works. So I guess then the question is, are your streets lit for real world conditions? So we know we've talked about it today. So this is just to sort of wrap up. Traffic patterns change due to incidents, events, and disruptions. So, lighting can respond when maybe visibility suddenly changes because weather conditions can rapidly affect road visibility as well. Is our lighting aligned with real world safety needs? Different users and different environments require different lighting levels, so we need it to be adaptive. We know that street lighting can account for up to 40% of a city's electricity bill, and therefore, if we're not needing it, let's reduce it. And how easily can lighting adapt without manual action? So, like I say, we know that traditional adjustments are quite slow and resource intensive, whereas if you link them directly into data, things can adapt a lot quicker, and we can get really quick action. So I think finally, our solution, as you've seen it today, it offers a cutting-edge approach to urban lighting, enables real-time adjustment of brightness levels based on traffic density, and in the future, coming very soon, prevailing weather conditions. It integrates seamlessly with other, smart city platforms, IoT, and different systems, ensuring that the lighting responds intelligently to the dynamic environmental factors. I think the benefits, as we've seen, are pretty multifaceted. We've got enhanced safety through improved visibility. It reduces the likelihood of accidents, and also the energy efficiency there means that we can save compared to traditional systems as well. I think sustainability is a core advantage. Reduced energy translates into lower carbon emissions, so that supports what Dave was talking about earlier around these city, municipality, and global environmental objectives that we have. Scalability is obviously a big key feature as well, and often what customers are asking for. And you can see today that this solution will allow to be implemented across existing infrastructure without extensive, costly retrofitting. Moving forward, and Dave touched on it just a minute ago around AI, I think will include moving forward more predictive lighting capabilities that, why not in the future we can anticipate changes in traffic and weather by using data, ensuring proactive adjustments rather than just reactive responses. And I think additionally, the system offers that seamless integration with, traffic management systems. So it creates a really holistic approach to that sort of urban mobility and safety. So I think by adopting this type of technology, cities can position themselves at the forefront of innovation and really deliver tangible improvements in the quality of life, operational efficiency, and environmental stewardship as well. So I just wanted to say thanks for everyone's attention. Hope the session sparked some ideas and highlighted the potential of adaptive lighting to improve the safety, reduce energy costs, and support your wider smart city ambitions.